Hello, everyone. Good morning. How are you? Good. So are you ready? This is going to be a change in pace as well as content. My talk is going to be slightly fast-paced, as usual, and it's going to be very technical. So I've been working with SVG for the last 3 years, and I've also been watching other developers work with SVG as well. And one of the things that I've noticed, besides the fact that they're using SVG more, which is really good, most of the use cases for SVG that I'm seeing is either displaying icons or illustrations or animated icons and illustrations, or maybe even data graphs or something like that. So they're actually making really good use of SVG as an image format, resolution independent, which is really good. But SVG is both an image format and a document format, and which makes it really, really powerful. And it's the document part, the document features that come with it as an XML format that make it also extremely powerful, and you can use it beyond the regular everybody uses that kind of stuff use cases. And this is what I'm going to talk about. Actually, did you know that SVG is so powerful that in Doctor Who Season 7, Episode 2, I don't watch Doctor Who, so I have to memorize this, missiles are being guided by the power of SVG? So you have an SVG up there, and you have a path and all that stuff. So seriously, though, there is so much untouched or very little touched territory in SVG. I don't know if the reason is that developers are not digging enough into SVG, or they're just maybe not needing all of this. But maybe if they see some of the use cases, they start knowing that they need it, even though they didn't know that they needed it. So in this talk, I'm going to go over some of these examples, because time. But if you have any other intrigues, if you're intrigued about any other demos, I'm going to be showing just a couple at the end of the talk as well. So I'm going to start with cropping, scaling, preserving aspect ratio using SVG. And in particular, we're going to be cropping, scaling, and preserving aspect ratios of non-SVG images in SVG using SVG. Now, when we talk about cropping, scaling, and preserving aspect ratio in SVG, there are two attributes in particular that we talk about that do all of this work for us. It's the SVG view box, as well as the preserve aspect ratio attribute. So these two are the most powerful and possibly most underused attributes of SVG. Now, before we get into how these two work and how they can be used, we need to first make a differentiation between what an SVG view box is, which is the attribute, and what the SVG viewport is. So the SVG viewport and the viewbox are very, very different. The viewport is the viewing area of the SVG. You can think of it as a window through which you can see a scene, some scene, just like any other window. When you look outside of that window, you can either see an entire scene or you can see only part of that scene. Now, the size of that window is determined by the width and the height of the SVG. For example, the black borders in this example, do I see my mouse? No. Okay. So the black borders in this example are the borders of the SVG. These borders are defined using the SVG width and the height attributes, or you can do that in CSS as well. The viewport is what the browser uses to determine how the SVG behaves in the context of the page. So it's very similar in this regard to HTML elements, who also have a width and a height, and the browser uses these dimensions to place the item into the page layout, and then it determines how it behaves in that context. And just like HTML elements, these dimensions establish a coordinate system on the SVG, known as the initial coordinate system. It is one of the things that I personally don't usually stress about, but what you're going to discover is we have two coordinate systems in SVG. This coordinate system is not what it may seem at first, so it is not used to draw the contents inside of the SVG. The contents of the SVG are drawn on a conceptually infinite canvas inside of the viewport. So again, the viewport is the borders of the SVG, and inside of that SVG, so it's the window, and inside of that window, it's like some sort of second level. I like to think about it in terms of levels. So you have the page with the SVG borders and stuff, which is the viewport, and then there's like some sort of behind level, another layer, actually, not level, another layer, which is a conceptually infinite canvas where all of the drawing happens. Now the canvas, the main definition is, it is the space or area where the SVG content is drawn. Conceptually, this canvas is infinite in both dimensions. The SVG can therefore be of any size. However, it is rendered on the screen relative to a finite region known as the viewport, which is our width and height. Areas of the SVG that lie beyond the boundaries of the viewport are clipped off and not visible. Now, I like to think of SVG in this sense as similar to Google Maps. So you only view a very small area, but then you start dragging the map and you start seeing more areas of that canvas that you have in the back, sort of. Now, I always visualize this in my head by thinking about the SVG as a small rectangle and then imagining a layer in the back. But in order for the browser to draw things on that layer, on that infinite canvas, it needs a coordinate system. And that's what the viewbox is for. So the viewbox defines how the contents of the SVG inside of the SVG will be drawn, and then how they will behave in the context of the viewport. So you have viewport, context of the page, and then viewbox, context of the viewport. Again, 2 layers. So yes, we have 2 coordinate systems. One that defines how the SVG behaves. I'm repeating a lot because viewbox versus viewport can be a little bit confusing if you're not really used to it. So we have 2 coordinate systems, one that defines how the SVG behaves in the context of the page, and the other one defines how the contents of the SVG behave inside of it. Now, the coordinate system created by the viewbox inside the SVG is called the user coordinate system. So we have initial coordinate system on the viewport and user coordinate system inside of the SVG, which is confusing as hell. Now, it is defined and modified using 4 numerical values in the viewbox attribute. So this is what the viewbox looks like. It has x, y, width, and height. And just like any other coordinate system, the x and y determine the top left corner of the viewbox, and the width and the height determine the width and the height of the viewbox, which is the coordinate system inside the SVG. Together, these values make up the coordinate system where all of the SVG drawing takes place. And they are initially identical to the viewport. So this is where things start to get a little bit confusing. The viewbox is initially identical to the viewport. So when you create an SVG in Illustrator, for example, and you export it, it's going to have a width and a height, depending on how you create it. If you look at the viewbox that is going to be exported by default, you're going to notice that the width and the height on the viewbox are exactly the same as the width and the height of the SVG itself. You can change the x and y values and move the entire canvas within the viewport, and you can change the width and the height and make the canvas expand or shrink. It's magic and it's beautiful. So I'm going to start with a live demo here. Let me first switch displays. Okay. Yep, there we go. It works. Okay. So this is the demo that I created when I was first learning about the viewbox and the viewport and the preserve aspect ratio. It took me 2 weeks to actually get to an aha moment, and I was only able to do it when I was able to finally visualize it. Now, I want you to keep in mind here that this entire thing here is the SVG, and this parrot here, it just happens to be alone, and we just happen to have a lot of white space, but this could as well be any other illustration. Okay, so in the gray, let me just make this different. So the gray coordinate system is the initial coordinate system established on the viewport by the width and the height. I told you this is going to be technical. And the blue coordinate system is the coordinate system established by the viewbox. Okay, they are initially identical. Now, if you start changing, for example, I'm not going to change the position right now because that would take us into a lot of out of the scope stuff. So let me just stay with the width and the height here. If I change the width and the height on the viewbox so that it has a different aspect ratio different from the viewport, what the browser does is, so this is the canvas that we have, and the browser is going to fit the entire canvas into the viewport, even if that means having some white space at the top and at the bottom of the viewbox. See, it's confusing. Now, then we have the preserve aspect ratio attribute. It takes 2 values. One of them is called align, and the other one is either meet or slice, which is one of these 2 keywords. Meet is very similar to the contain attribute on CSS background images. So if you have a background image, which is not the same aspect ratio as the HTML element, and you tell that you want the background size to be contain, the browser is going to scale it as much as possible, all the while keeping it inside the boundaries of the element. So it's going to have some white space on top and bottom. Whereas if you choose slice, slice is the same as cover in CSS background images. So if I choose that, the browser scaled it up so that it covers the entire viewport area. Now, this is not going to actually be white. Again, it's only white because my canvas has a lot of white space. But it would be, just like background images, you would have the image inside of the SVG scaled up as much as possible to fill out the entire viewport area. And it's going to be centered by default. So if you want to move it, for example, if I do want to show you the parrot, if I choose x min, y min, which is the minimum of the x-axis and the minimum of the y-axis, which in other words means the top left corner, if I choose that, you're going to see it. Again, it's covering, we have a different aspect ratio from the viewport, but because I chose x min, y min along with slice, I was able to scale it up. And if you notice, the parrot right now looks a lot bigger than it looked by default. Okay? I know it's a lot of stuff. So we have the viewport, and then we have the view box. If you think about it just like CSS background images, it becomes much more simpler. And if you do want to check this demo out, I have this cheat sheet. For example, suppose you want your image to be always a square image, such as author bios, for example. They're usually square. And you set the dimensions in ems to be 5em by 5em, for instance. And then you provide your users the ability in a CMS to upload their image, actually, their photo. Now, using object fit, you can crop the image to the 5em by 5em dimensions using only one line of CSS. Now, the following images demonstrate the stretch effect, basically what object fit does. So if you have this image here, and we want to crop it to this square area, you can choose fill. What fill does is it does not preserve the aspect ratio, so it's just going to fill the square area and it's going to make it shrink, sort of. Contain is very similar to what we saw in SVG. It's going to scale it up as much as possible, all the while keep it contained inside of this square area, which means we have white space. Cover is probably going to be the most used one. So you scale it up as much as possible, you crop it, and it's going to be centered by default. You also have none, which means that the image is not going to be changed at all. It's just going to put it inside of the square area, and it's going to get cropped, maybe in non-ideal ways. And scale down is very similar to contain in the effect. But browser support is not really good. So if you want, you can use this as an enhancement using the supports rule. So again, IE is always the culprit as usual. And even Edge does not support it right now, but it's coming in the next version. So you could test for browser support, and then you can crop your images if the browser supports object fill. But if you still need to support IEs or even Edge, or maybe you just don't want to use the supports rule as an enhancement, there is another way. You're probably going to think of another way to do it cross-browser. So you could crop the image on the back end and then send it to the front end and then display it, but you don't even need to do that because of the power of SVG. So we have this snippet here. This snippet is all you need. I could just finish this presentation right here, actually. Well, not really. I have 3 more sections. So SVG, suppose you want to, so SVG width x, height y. X and y are the height of the image, the way you want it to be in the page. If you want it to be square, it would be 200 pixels by 200 pixels, for example. The view box would take 0, 0. We're not going to change the top left corner at all. The image x and image y are going to be the width and the height of the image that the user is going to upload. Preserve aspect ratio, the values are your choice, so you can choose to crop it and scale it up and down any way you want to. And then you reference that actual image, the URL of that image, you put it in here, in the xlink href, and you're all done. This snippet here can replace the image tag in your HTML. It gives you the ability to crop and scale images without using any line of CSS, and it is much more cross-browser compatible. So to continue with this example, if you want the image to be 140 by 40 pixels and the user uploads an image that's 800 by 500 pixels, you put these values like this, x and y. Preserve aspect ratio, I kept it, I didn't give it a value because it's going to be up to you. Meet or slice if you want to scale or fit, and then you can position it. And then a link to the image here. So you can substitute your image, the image tag in your HTML with the snippet and get the image cropping and positioning out of the box, straight in the markup without any CSS. But if you compare this snippet to an image tag, there is something very important missing. What is it? Alt tag. Yeah. Alt tag. I knew you were going to have the answer. So you must never, ever serve an image without an alt tag. Okay? Even if the image is just decoration, keep the alt tag empty, but do not omit it. It's very necessary. Now, we don't have an alt tag for the image element in SVG, but we do have an alternative in SVG in general. Now, the whole SVG, it can be made more accessible using the title element, which is used to describe its content, which is very similar to the alt attribute on the image tag. You can even elaborate on the title using the desk element. So basically, you would have title and description. It depends on the use case. I personally don't use desk much. So this code would look more something like this. So you would just add the title. It has to be the first element inside of the SVG, inside of the container, actually. So you can use the title on any container element in SVG, including a G, including a symbol element. It just has to be the first one as the first child inside of that container. And the best thing about this technique is it works across browsers. Every browser that support SVG can get that cropping. Only IE 8 and below, Android, I think it was 2.2 and below, so really old browsers. I'm not really sure. You could maybe use some other like server side or something technique in order to provide for those if you really have to. Now, suppose that you have cropped your image to square dimensions, and the next step is to make it responsive. Maintaining aspect ratio in CSS while making the image fluid is not really easy. So if the width is 100%, how do you tell the browser that you want the height to also be 100% all of the time? Usually, one of the most common use cases is having a big header section, and where you would have a background image, and you want to preserve the aspect ratio of the whole section to match that of the background image. So how do you do that in CSS? Now, this is actually this preserving aspect ratio as the image is fluid is also one of the problems of SVG when it is embedded inline. So you have multiple ways to embed an SVG. One of them is inline inside of the document. And if you set the width to be 100%, all of the browsers are going to make it scale as you would expect, including preserving the aspect ratio. Because all modern browsers are smart enough to, they just use the viewbox value and then use that to preserve the aspect ratio of the SVG, except for IE, because IE is dumb. So what IE does, there is something called replaced element in CSS. A replaced element is, for example, a video or an iframe or an image. Basically, it's any element whose contents are defined outside of CSS. So if you upload an image, that image is going to have a size, width, and a height defined by the pixels inside of that image, right? So an image is a replaced element. By default, if you don't give your replaced element, such as an iframe, for example, if you don't give it a width and a height, the browser is going to give it 300 pixels by 150 pixels, because this is the default size of replaced elements in CSS. Now, what IE does is, if you place an inline SVG, inline in the HTML, and you give it, like you just leave it there, you don't specify a width, you want it to be fluid, it is going to make the width fluid, but it's going to fix the height to 150 pixels. I don't know why, but it does it. So in order to fix that, if you're embedding the SVG using an image tag or using an object tag, you have to explicitly tell IE that the width is 100%, so that it can fix the height, even though it's already setting the width to 100%. Anyway, it's just too dumb. So in order to fix this inline SVG scaling thing, responsive scaling in IE, you're going to have to use something called the padding hack. So to make an SVG responsive with a preserved aspect ratio, you first wrap the SVG in a container. This might as well also be if you embed the SVG using an iframe source equals something.svg. The padding hack is required for all browsers, not just IE. So it's something that you should know how to do. So you wrap it in a container, and then you collapse that container's height, give it a height 0, and then you set the width, whatever you want. So let's say, for example, it's 100%. And then you set a padding top. The padding top is going to be SVG height divided by SVG width times the width value that you have. So why are we doing this? In CSS, when you set a padding value, whether it's a padding top or even a padding bottom, if you give it, for example, padding top 50%, 50% is going to be relative to the width, okay? So if you have an element that has 0 height, and you give it a padding, you're going to expand that height again. But this time, the height is going to be relative to the width, because you're doing it with a padding, which is relative to the width. And this way, you're establishing a certain specific aspect ratio. And the math for that, which is not really complex, is you give the width value whatever you want, and then you divide. You're essentially taking the aspect ratio of the SVG, the aspect ratio that you're after, and then you're multiplying it with the width that you have. You set position relative so that you create a positioning context. So if you have the container with a height 0, you still have the iframe or the SVG inside of it, and now the SVG is just hanging there. It's not really inside of the container. And when you added the padding to the container, the SVG was pushed down. So you want to pull it back up using absolute positioning. Okay? That's why you set position relative on the container, and then you go to the SVG and you position it absolutely inside the container. And this is what it's like in action. Okay, so what I have here is I have this SVG in the black borders. I have an image inside of it, which is 450 pixels by 150 pixels. I'm going to read it here. The width and the height of the SVG are 300 by 200. And the image inside of it has apparently a very different aspect ratio. So in the code here, I don't know if you can see it. So I have the SVG container. I've given it a width of 75%. The height is 0, and the padding top is 50%, because the padding top is 200 by over 300 times 75. This is how it works. So if you scale up and down now, it's going to scale up and down. If I want to change something, it's not playing here. So if I changed from meat to slice in the preserve aspect ratio on top, the image now scales up so that it fills the entire viewport. And if I want to change the width and the height on the SVG, so I made it 300 by 300 now, which is a square, the padding top has to change. And again, using this math, I preserve the aspect ratio of the SVG and its content. And that's it for this section. Optimizing image sizes with SVG masks. Now, JPEGs have better compression rates than PNGs for photographic data. If you have a JPEG image and you have a PNG image of this PNG version of the same image, and you compress them, the JPEG is going to be much smaller in size. Now, wouldn't it be awesome if you could get the compression of a JPEG image, but also get the transparency of a PNG image at the same time? That is possible with SVG as well. Now, again, SVG here in this example is going to serve as a mere container, just a document, essentially, not a real image. It's going to be a container for the bitmap image, and then we'll use some SVG magic on it to get the compression result that we want. So the idea behind this technique is to use an SVG mask to clip out or mask out the areas of the JPEG that we don't want. So we get the JPEG served, but we're also making it transparent where we want it to be transparent using SVG masks. So we're serving the JPEG image essentially with simulated alpha channels, thus combining the transparency of PNG with the compression of a JPEG. For example, suppose that you have the following image here on the left. The image on the left is what we want to serve as the PNG. So we start out with the JPEG version of it with no transparent areas. And then to achieve the transparency of the original background and only keep the bird image, we're going to use a luminance mask. So what I did here is I created a luminance mask out of the JPEG. So in our case here, the white, the luminant areas of the mask here represent the areas of the JPEG that we want to keep, and the black areas are going to be the areas that are going to be masked out. So you have an SVG that contains a JPEG. You're serving a JPEG, which means it's much smaller in size, but you're also making it transparent just like a PNG using an SVG mask. And you can apply that like this. So the mask image here, we have the SVG defs element. Defs is sort of short for definitions. Everything you put inside of a defs element is not going to be rendered on the page. So if you want to define linear gradients, for example, or masks, or any kind of effect, or even elements that you don't want to display yet, you can put them inside of defs, or a symbol, but that's another thing. So we define our mask inside of a defs. The mask is actually an image. So we're referencing an image inside of a mask. You give that mask an ID so that you can actually apply it to your element somewhere else. And then the JPEG image is over here, and you're applying the mask to the JPEG image using the URL notation, and the mask attribute. Of course, since this technique relies on SVG and SVG masks to work, it will only work in browsers that support SVG, again, all the way back to IE9 stuff. And also, it's also recommended that you inline the SVG to make it work in most browsers, because referencing an external SVG containing the images using an image tag, for example, does not work in all browsers. Now, just like we can optimize the delivery of non-vector images using SVG, we can also optimize SVG delivery using SVG, so essentially SVGception. And this is my absolutely favorite part. So I worked on the new Smashing Magazine redesign, I think it was 1.5 years ago. It's been a year, I'm not sure. So yeah, last year, essentially. So these illustrations are not the same anymore, they have changed, but technique behind them is still the same, and I was too lazy to change them, so I just kept them. So we have these 3 membership options in the new Smashing Magazine, okay? And these memberships are presented with these 3 illustrations. Now, the text inside of these illustrations, the supporter, the member, the I Feel Smashing, which also maybe have changed, this text is the actual title of every section. So we don't have, for example, an H1 or an H2 that says supporter membership followed by this. The image is the text. So as you can imagine, the text needs to be searchable, selectable, accessible. So if the user wants to select it with a mouse, they should be able to do that. If the user wants to, well, screen readers should be able to read it and everything. So it has to be treated just like HTML text in an HTML page. So the best way to do this, in my opinion, was to put the SVGs in line, because when you have an SVG inline in an HTML page, the text inside of the SVG, if you keep that text as actual text and don't convert it to outlines, the text is going to be searchable, selectable, and accessible. So I thought, okay, it was an easy call. I just inline them. But it's not easy to inline them when each one of them looks like this. It's not finished yet. So we have 3 of these. There was no way I was going to put these inline in the HTML. And I also didn't want to put them not inline because I wanted to apply the font face that we were using. I wanted to apply it to the text. Now, sure, okay, if you have an SVG that is referenced externally, so you have some reference to some SVG, and that SVG here on the other side, it has text. Now, you can go into the SVG and define the font faces that you want to use and then apply them to the text inside of the SVG. But that would mean that you're going to have to maintain your fonts in 2 different places. The one is the HTML page, your actual page and content, and then you also have the SVG. Or you could even define them in an external style sheet somewhere and reference that style sheet inside of the SVG. I'm too lazy, and that was too much work, in my opinion. So I thought there must be another way. I didn't want to inline them. I didn't want to reference them externally, but I still wanted the text to be inline. So I wanted the text to be inline, but the images were too big to be inline. So I thought, why don't I separate them? I mean, SVG is a document, okay? So I have these illustrations with the text inside of them, and it's actually a document, an XML document. So why don't I just go into that SVG, take the text out of it, and put that into the HTML page, and then I reference the rest of the illustration externally. That should work. So I did it like this. So I have an SVG inline in my page. I given it a title because it needs one. And then I reference the illustration part, the complex illustrations, using an image. So I'm referencing an SVG inside of an SVG right now. The image in this case can be cached. It's much more performant, and it works, which leaves me with the text. I added that manually with a text element. I positioned it so that it's positioned correctly inside of the SVG, and I always keep the slide because you should never write text in all caps in your HTML. If you want to make it all caps, do that inside of the CSS, because otherwise some screen readers are going to read this out loud as SUPPORTER. It's not going to read supporter. So keep this small caps and then change it in your CSS if you want that. And because I wanted to apply a font face, and because you can style SVG text just like you can style HTML text, you just go into the CSS and you say SVG text, font family Mihao, which is what we had for the Smashing magazine. Instead of color, you use fill. I gave it color white and font weight bold. This is pretty cool. And this is only possible because SVG is also a document, not just an image, just like any other image format. Okay. We also have conditional processing in SVG, or a native SVG XML way to provide fallbacks for SVGs and non-SVG supporting browsers. So the SVG document structure specification defines elements and attributes, namely the switch element, and it has 3 attributes. It's called required features, required extensions, and system language, which is a bunch of blah, blah, blah for me, actually. That gives us the ability to specify alternate viewing depending on the capabilities of a given user agent or the user's language. So the 3 attributes act as tests, just like an if-else statement, and return either true or false. The switch renders the first of its children, for which all of these attributes test true. If the given attribute is not specified, then a true value is assumed. So suppose we have something like this. We have an SVG, we have a switch element inside of the SVG, which is sort of like switch in JavaScript or an if-else. If the browser supports SVG, it's going to use the use element here. So we're referencing some icon somewhere that has an ID, icon Twitter. And then if the browser, as soon as the browser supports SVG, it's going to render this one, it's going to stop there. It's going to render the first element, it's going to stop there. Now, if a browser does not support SVG, it's going to ignore this, and this, and this, and this, and it's going to go straight into the fallback div. So the fallback div here is literally a fallback div. If SVG is not supported, our illustration is not going to be rendered anymore. So what we do is we have an empty div, and the illustration that you want to display is used as a background image for that empty div. So the CSS would look something like this. Now, why am I using a background image instead of a regular image? Because we want to avoid multiple downloads. So the icon.twitter fallback div here, it will be rendered in IE, but not in SVG-capable browsers. However, some SVG-capable browsers will still download the fallback image or background image even if it is not needed. So the folk behind Hi Robotics came up with an interesting technique to avoid this double download issue. So the idea is to add another SVG in the same document. Okay? So you have this SVG inline in your page. And so you add another SVG in the same document that contains styles that are going to be applied to this SVG. FYI, if you have one SVG inline in your page and you have another SVG inline in your page, this one has an element with an ID icon, and the second one also has an element with an ID icon. And the first one contains the styles that are applied to the ID icon. Those styles are going to be applied also in the second SVG as well. Okay? So an SVG can be used inline to style another SVG that is also inline. And using this technique, we're going to tell the browsers that do support SVG, they're going to get into this style element here, and they're going to be like, okay, the fallback, it doesn't have a background, so I'm not going to download that. So you're using SVG to style an SVG to avoid double downloads in browsers that support SVG. Now, there are multiple ways to provide fallbacks for SVGs depending on the way that you're embedding the SVG. You can also embed an SVG using an object tag, for example. And with the object tag, it's going to have the same problem. If you're referencing an SVG image, for example here, icon_twitter.svg, and you want to provide a fallback, anything you provide between the opening and closing object tags are going to be used as fallbacks in browsers that don't support SVG. Okay? So again here, you're going to provide another image as a fallback, and you can also avoid this double download issue by using it as a background image and then telling browsers that support SVG that the background image is not there. Confusing much? But pretty cool, pretty awesome. Now, SVG can do a lot more. I'm going to go back into the previous mode. Let me go into the browser. So I don't know if any of you have noticed this timeline of Syrian history. I'm not really into history, so this is just an SVG demo here. It's messed up because of the resolution, but it still allows me to show you what it can do. So this is a demo that one of the attendees last week showed me. This is all SVG. This map that you're seeing here is all SVG. So this map here, the ground stuff, it is a bitmap image. He's referencing the bitmap image inside of the SVG, and then all of this text and all of these small circles and stuff, and even this blue line, this is all SVG paths. So you can do something like show on map. It's going to highlight. Let me just do another one. So I think, yeah. So you can highlight stuff like this. And then you can use, we also have effects in SVG, such as drop shadows and blur effects and all of that kind of stuff. So you could do something like this. You could highlight things using SVG. So what we're doing here is he has like 3 paths, I think, and they have a fill color, and then he's applying a blur to those. So you can highlight heat areas on the map using this kind of stuff. And another thing you can do with SVG as well is this demo, which I happened to see on Twitter today. So what they're doing here is you can lazy load images with inline SVGs. You're actually making the lazy loading more interesting. You can't see it here because I'm not sure if I can connect it to Wi-Fi. But essentially what they're doing here is instead of showing this image at first, at the beginning, they're showing a black and white sort of illustration of that image that represents that image. That's going to be shown by default, and then as the rest of the images start loading, you're going to be able to see those. Let me see if I can get, no, Wi-Fi is going to be an issue right now, so I don't even know the SSID. So SVG, again, here is used only as a mere container that provides a really nice visual fallback while the images are being lazy loaded, which is pretty cool. And my next slide is a thank you slide, so I can just play it here. So thank you very much.